We continue to work in Chapter 3, and today we spent time working problems 3.2, 3.3, 3.4, and 3.5 actually. So here are the problems from 3.2. Pretty straightforward. We're asked to add these two fractions, and you'll notice we do not have a common denominator, or the denominators are not equal. And we have two techniques for determining the lowest common multiple. One is just to simply make yourself a table of common multiples and look something like this. And you can tell in this setup that the first common multiple that we're going to encounter is in fact going to be 20. Now, another test you can use is if you can multiply the smaller value times a whole number and get the larger value, then that's generally going to be your lowest common multiple. And so in this case, it is. The other method we had was to factor and then bring down the common factors, the greatest number of times they occur. So 5 is a prime number, and then 20 will factor into this. And so we bring down the factors, the greatest number of times they occur in any one factorization. So the 2 comes down, the lowest common multiple, 2 times 2, and then we get 20. So we got more than one way to figure out that it's 20. And so I need to turn that into 20 for, so that becomes 8 twentieths plus 3 twentieths is 11 twentieths. Now remember, once we get this denominator to be the same value, we do not do any arithmetic with it. We do all the arithmetic, the addition arithmetic in this case with the numerators. And this one can't be simplified, so there it is. So here's a simple word problem, and says that we have a piece of wood that has a thickness of paint that is 1/21 inch. And the piece of wood that it's on is 6/7. And so the question is, what is the total distance or the total thickness? So it's just a straightforward addition. So 6/7 plus 1/21. And again, without thinking too much about it, I think you can tell that the lowest common multiple is going to be 21. So 6/7. And I want it to become 21 times 3 times 3 plus 1/21 is 19/21. And so there's our answer there, answer choice B. So this one was C and this one's B. And we can just look at those answers on the back side here. C and B. So we got those right. Here's a couple of subtraction problems. When we're doing subtraction, we have the same issue with denominators. We must have like denominators. And I think you can tell in this case that it's going to be 12. So I want this to become 12ths, right? And I already have that one in 12ths. So now I get 8/12. And we can simplify this by either cancel out a common factor or dividing through by the greatest common factor. And if you want me to factor it, I will. 2 times 2 times 2. And this is what? 2 times 6, which is 2 times 3. And so what is the greatest common factor here? Well, the greatest common factor is going to be 4. So cancel that out, and you're left with 2/3. Alternatively, divide by 4, and you're also going to get 2/3. And so there's the answer there, which is answer choice A. From a 7/8 pound, we remove 1/4 pound. How much is left? 7/8 minus 1/4, 7/8, and this I'm going to turn into eighths. and I get 5/8 left. And so there's the answer to that one. So both of these had A as their answer. I hope I'm not going, let me see, can you see that? There it is right there. I hope I'm not going too fast on this. So let me just kind of go back now. Again, we've talked a lot about this common denominator issue, and we have two methods for getting it. We can either do a table of common multiples or we can factor. In this case, I said, oh, and by the way, when you can multiply the smaller one by a whole number and get the bigger one, that's it. So in this case, 3 times 4 is 12. Likewise, down here, 2 times 4 is 8. So in this case, I knew it was 8, and in this case, I knew it was 12. Convert so that you get equal denominators, and then do the arithmetic on the numerators. All right. Now, we spent most of the time today in the calculations dealing with mixed numbers. And one of the very important ideas that we have with mixed numbers is we must have the ability to move and transfer, change, convert easily between a mixed number. And what is a mixed number? Well, a mixed number is a whole number plus a fraction. And you can think of many situations where you've had an entire object and then part of a separate and another object, like an entire pizza and a part of a pizza, for example. So in this case, we have 8 entire objects and 3/5 of another one. And we want to convert that to fraction notation. What it literally means is I'm going to convert all of these 8 of these wholes with 5 parts each to make a whole. So what do I have here? Well, I'll have 8 times 5, which is 40, plus 3, which is 43 over 5. So again, just think about this for a second. I have some objects, and for each object, it takes 5 to make the whole. 1, 2, 3, 4, 5. Okay, not to scale, but I think you can see what I'm doing. 1, 2, 3, 4, 5. In one case, what do I have? Well, I have 3/5. 1, 2, 3/5. So there's my 3/5. Now, I have 8 of these, not just one, but I have 8 of these. So any way you want to look at it, 8 times 5 is going to be 40/5, right? So 40 plus 3 is going to be 43/5. When you're doing calculations with mixed numbers, you're going to find yourself converting from the mixed number form to what's referred to as the improper fraction form. And I think in our literature, we just call it fraction notation. And this is actually referred to as an improper fraction because the numerator is larger than the denominator, meaning we know we have enough pieces here to put them back together to make some entire objects. So the shortcut method, rather than doing all that, the shortcut method is to simply say to yourself, well, I have 7 3/5. So I multiply 5 times 7, and you see the logic there. 7 items, it takes 5 to make the whole. I've got 7 items, it takes 5 to make the whole. And so I must have 35 pieces here if I broke these all out into pieces. Think taking a dollar bill and converting it into change. So 7 times 5 is 35 plus 3. So I get 7 times 5 is 35 plus 3 is 38/5. So the answer to that one should be 38/5. Now, here we're going the other way. We're going from the fraction notation or improper notation, we're going to a mixed number. Now, the easiest way to do this is to say 41 over 3 could be rewritten as 41 divided by 3, which just do old style division here, and you're going to get right. So in our whole number division world, we would say this is 13 with a remainder of 2. 13 with a remainder of 2. But what we want to do with fraction notation is we want to say, okay, I do have this remainder of 2. However, I'm still attempting, to do the division by 3. You can think of it that way. So you can write this as the remainder and this as the denominator. If you want to think about this a little differently, you have 41 items and it takes 3 to make the whole. So we know that we have enough parts of 3 to make some wholes. So the question is, how many entire objects can I make? Well, I can make 13 entire objects. That is, I can put 13 groups of 3, which will give me, 39? And then I actually have 2 more for 41. So there's more than one way to look at this. To check this, just multiply and add. Hope that's pretty clear. Here, same idea. 24 divided by 5. Remainder of 4, 4 4/5. This one you could think of maybe if you wanted to draw a picture. I don't know that we need to, but if you say, well, I have some object that's divided into 5 pieces, okay, and so there's 5. There's 5. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4, 5. I'm not to scale. So each of these should contain 5 pieces. And you say, well, how many pieces do you have here? Well, I have 5 here, 5 here, 5 here, and 5 here. So altogether, how many pieces do you have? Well, I altogether have 20 pieces. But, oh, you told me you had 24 of them. Well, I sure did, because what I said was 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Is that I have not this entire piece, but I have a part of it. So I have 4/5 here. In each one of these, I had 5 out of 5. Right? So I had 20 and 4, or 24/5. So I had 1, 2, 3, 4 complete items and a part of another one, which was the 4/5. Okay, let's turn the page. So the answer to that one is B here. The answer to this one is 4 4/5. And did we say what the answer to this one was? The answer to this one was C. So 3 is C and 4 is B. 3 is C and 4 is B. 3 is C and 4 is B. We got it right. Now page 5. This is the same idea, just written as a division problem. And so what do I mean by that? This is the same idea. 5,257 over 105. So this is some strange situation where it takes 105 items to make the whole, and I have this large number here, 5,257. So what am I going to do? I'm just going to divide. I'm going to say 5,257 divided by 105, and 5, that looks good. And 7 left over. So I have 50 and 7 out of 105. So I have 50 and 7 out of 105. Oh, I do not see that answer here. Okay, so they simplified this. And it turns out that you can divide by 7 here, and you get 50 and 1 over 13. Now that might take you a little thought process to do that. Now I think I'll just use this problem to kind of demonstrate what our calculators can do for us. So if you take this problem as it sits and put it in your calculator, you're going to get 5,257 divided by 105. And I'm trying to hold this where you can see the display. And so we get an answer. You say, what is that answer? Well, it's an answer with decimals. Now, what did I want? Oh, I wanted an answer with fractions. So, second fraction decimal, enter. And there's my answer with the fraction, 50 and 1/15. This little symbol is the separator between the whole number and the fraction. This is not some odd math activity. It's just the symbol that this calculator uses to show you that here are the whole numbers and here are the fractions. Now, I want you to notice that the calculator went ahead and simplified that for us. When we did the division manually, we wound up with an answer of a remainder of 7 over 105. And you could, in fact, simplify that down to 1 over, I said 1 over 13. It should have been 1 over 15. My bad. So you could simplify it down. So the calculators will do the work for you and will also simplify the fraction. This one is going to be the same process. We're going to say 26 into 1549, and what is this, about 7 maybe? 7 sixes, 6. I'm just doing a little arithmetic in my head here. I think it's going to be 5. 5 times 6 is 30. That's 130. 4, yeah, that's about right. And this is what, about 7 maybe? 8. Let's just use a calculator. We got it. We might as well use it. So 26 times 8 is 208. I think we can go a little bigger, can't we? So 26 times 9 is 234. So, yep, I can make that work. 9 minus 4 is 5. 4 minus 3 is 1. And I get 15/26. So the answer I have is 59 and 15/26. And so would be answer choice B. Now, we want to do some addition arithmetic with mixed numbers. Notice that I have no parts and pieces here. It's one whole item. So in this case, I'm just going to combine the whole numbers and get 6 and 2/7. It's pretty easy. Now, notice we have whole number, fraction, fraction. So we can add whole numbers. We know how to do that. We also know how to add fractions. And in this case, we can tell that we're going to have a common denominator. So if I rewrite this in a vertical form, just so we can see what we're doing, and I say, well, 7's okay, 6 is okay. Now, do you see the logic that I'm going to use to say that the lowest common multiple and lowest common denominator is 18? Times 9, times 9, times 2, times 2. What am I going to do now? Add the whole numbers, add the numerators on the fractions, and I get 13 and 11/18, which is that answer choice there. So we can add fractions, we can add whole numbers. So we're just putting those activities together in these problems. Now, the work gets a little more complicated. The work gets a little more complicated when we have to subtract mixed numbers. And you'll notice that this problem starts out with the same denominator, which is okay. But I want you to notice that we're going to try to take 2 from 1. 2 from 1. And you think about that for a little bit and you say, well, I don't think I can do that. But here's what you can do. Here's what you can do. You can say to yourself, now, I'm going to take 1, and this is going to look like regrouping, and it is regrouping with fractions. So I'm going to take 1 away from 13, and that's going to leave me 12. All right. So I took 1 away and left me 12. Now, what happened to the 1 that I took away? The 1 that I take away, I'm going to break it up, separate it up as 9/9. Okay? So, that allows me then to convert one of my whole items to pieces, 9/9. Why 9? Why 9ths? That's the denominator. I have 1 to start with. 9 more gives me 10/9. And at this point, I think you can tell we can do this subtraction pretty easily. 10 take away 2 is 8, and 12 take away 6 is 6. So the answer to that should be 6 and 8/9, which would be C. All right. Now, here's another subtraction problem. Notice we do not have a common denominator, so we're going to have to, I'll just try to do some work right in here. So same process we've been doing. We got to find a common denominator. Okay, and I hope you see that the common denominator is going to be 10. And so 5 times 2 here, 2 times 5 here, right? What did I do here? This is a 7, not a 13, obviously. So 13 take away 7 is 6, 6 take away 5 is 1, and I get 6 1/10. Oh gosh, I really garbled that up, didn't I? That's 15. 15 3/5. 15 3/5. I don't know what I was looking at. I was looking at another page, I guess. 15 take away 7 is 8. Okay, I hope it didn't confuse you too much on that. So this was 15 3/5, taking away 7 1/2. So the lowest common multiple is 10. 2 times 5 is 10. 2 times 3 is 6. 5 times 2 is 10. 5 times 1 is 5. 15 take away 7 is 8. 6 take away 5 is 1. So there is the answer for that one. Now, we stopped here today. We stopped. We didn't go ahead and do any multiplication work. So that means that we actually got what? We actually got all the way down through 3.5. And so in the next class, we're going to finish this up. I hope these problems are helpful to you.